Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review everything in the upcoming test. So that includes indices or index laws, linear relations, algebra, and equations. So let's start with index laws. So when you have something that looks like this, we call this number the base and this the index, hence the name index laws. Another name for index is power. Index laws have all to do with powers. This is read a to the power of b. It means you multiply this base by itself this many times. So you need to know these four index laws. So this first one just says when you multiply the same base, you add the powers. When you divide the same base, you subtract the powers. When you raise a power to another power, you keep the same base and multiply the powers. And this final one says that anything except 0 when raised to the power of 0 is 1. So like 2 to the power of 0 is 1, 3 to the power of 0 is 1, negative 4 to the power of 0 is 1, and so on. So let's look at some questions. You'll be given questions like this where you have to simplify your answer and write it in index form. So here the base is 2. We're multiplying bases, so we keep the same base and add the powers. 7 plus 11 is 18. So 3 to the power of 20 divide 3. Here 3 is the base. Now note 3 and 3 to the power of 1 are the same. Raising a number to the power of 1 doesn't change it. We need that power written here so we can apply this second index law. The second index law says when dividing bases, you keep the same base and subtract the powers. So this third one is a power to a power law. This is a to the power of 8 to the power of 4. So even though this used a pronumeral for a base rather than a number, we're going to do it the same way. We're going to use the same laws. So we're going to keep the same base and multiply the two powers. 8 times 4 is 32. All right, so how do we do something like this? This one looks a bit scary because we have to use multiple index laws, but we can still do it the same way. So what we're going to do first is the brackets. So 3 to the power of 9 to the power of 2, keep the same base and multiply the powers. So now we're going to multiply what's on top. 3 to the power of 14 times 3 to the power of 18, keep the same base, add the powers. Now note, fraction line means divide. Here we're actually dividing bases, so our final answer, we're going to keep the same base and subtract the powers, and we're done. So now we're going to calculate this without a calculator. So note 6 to the power of 0 is 1 by the fourth index law. So the difference between this expression and this expression, of course, is the brackets. BIDMAS means you raise the power first before multiplication. So this would be 4 times 1, which is 4. Now over here, because the multiplication's in brackets, we do it first. This is 4 times 6, 24 to the power of 0. 24 to the power of 0 is just 1. So our final answer is 4 minus 1, which is 3. Let's now move on to linear relations. So firstly, we need to be able to sketch linear graphs. So if I give you an equation like y equals 3x minus 2, you need to turn that into a graph. So how you do that is by drawing up a table of values. So we need a table that has x and y values. So always choose x values negative 2 to 2. What you do is you take each of these values one by one and substitute it into the equation to find the y value. So if x is negative 2, y is 3 times negative 2 minus 2, which gives negative 8. If x is negative 1, y is 3 times negative 1 minus 2, which is negative 5. So if x is 0, y is 3 times 0 minus 2, which is negative 2. Hopefully you can see a pattern here. We're just going up by 3 each time. And that's no coincidence. We're actually going up by 3 each time because this number's 3. So the relationship between x and y is linear because each time x goes up by 1, y goes up or down by the same amount each time. Each time x goes up by 1, y goes up by 3. That's what it means for a relationship to be linear. The reason we call it linear is if we were to plot each of these points, they would lie in a straight line. So linear basically means has to do with lines. So each of these is a point. Negative 2, negative 8 is a point. Negative 1, negative 5 is a point. So let's plot this. If we want to plot this point, we go across to x is negative 1, down to y is -5, which will be about there. So 0 minus 2, that's the point x is 0, minus 2 for y is there. Similarly, 1, 1 would be the point there, and 2, 4 would be the point there. This is how you turn an equation into a graph. You set up a table of values to find points that lie on the line, like we've done there, but you must remember this last step people often forget. You have to actually join up these points. So all I'm going to do is draw a line through these points. So this green line here, I'm going to put arrows because it goes forever in both directions. This is the graph of y equals 3x minus 2. All right, let's now look at doing the opposite of this. So here we're doing the opposite, because on the previous slide, I gave you the equation and you turned it into a table of values or a graph. Now, I'm going to give you a table of values or a graph to start with, and you have to find the resulting equation. So how do we actually do that? We're only looking at linear relations, and if the relationship between x and y is linear, you can always write the rule or equation linking them in the form y equals mx plus b. Your answer when finding the equation of the line will always look like this: y equals something times x plus something. This first number attached to x is known as the gradient. It is the rise over the run, or the change in y over change in x. So the gradient is basically just a measure of the steepness of the line. So if a gradient leans to the right, then it's positive. M is greater than 0 means gradient is positive. Leans to the left, you have a negative gradient. And if it is perfectly horizontal, the gradient is 0. So the higher the gradient, the higher the number, the steeper or more vertical the line is. The gradient is just the slope of the line. So the y-intercept of a line is where it hits the y-axis, or it's the y value when x equals 0. So this probably sounds pretty complicated, but it actually makes life easier for us. If I want to find the equation of a line, all I need to do is find the gradient, find the y-intercept, and then I'm done. So let's say I'm given this graph here, and I want to find the equation. What equation do you start with to end up with a graph like this? Well, I know because it's a line, it's going to be y equals mx plus b, where m is the gradient and b is the y-intercept. So let's find the gradient. The gradient is the rise over the run. How do we actually find that from a graph? Well, what I've always tell people to do is start at the leftmost point. To find the gradient, you need 2 points. So we start at the point on the left and we go right. So to go from this point to this point, we actually go across 1 to the right. So that means the run is 1. This number on the bottom of the gradient, the run, is how far you go right. What goes on top of the fraction is the rise, how far you go up or down. So to go from this point to this point, we go 1 to the right, but we actually go 2 down. So the rise is -2. It's negative because we went down instead of up. So rise is -2, that goes on top here. The gradient of this green line, rise over run, is -2 over 1, which is just -2. So I can change m, the gradient, to -2. Now note, it's expected that we got a negative gradient because this line leans to the left. So now for b, we need to change it with the y-intercept. The y-intercept here is just 2 because that's where it hits the y or the vertical axis. So I'm going to replace b with 2. Then I'm done. That's the equation of the line. If I asked you to graph y equals -2x plus 2, you'd end up with this graph. So how do you find the rule linking x and y, or the equation of a line, from a table of values? Well, the steps are very similar. Step 1 is to find the gradient. So the gradient is the change in y over the change in x. See, x is going up by 1 each time in this table. Y is going up by 4. We're plussing 4 each time. So it turns out the gradient is 4 over 1, or just 4. The y-intercept is the y value when x equals 0. So that's this value here. Here, the y-intercept is 11. So the rule linking x and y, or the equation linking x and y is just going to be y equals mx plus b. What that essentially means is that if you want to get the y value, you just times the x value by 4 and add 11. Times x value by 4, add 11, you have the y value, and so on. All right, let's look at this table of values. This one's a little bit more tricky because x is not going up by 1 each time. Here, x is going up by 3 each time. Y is actually going down by 9, so we need to minus 9 each time. The gradient is the change in y, how much y is changing, over the change in x. So the gradient's negative 3. What we found is if x goes up by 3, y goes down by 9. This means if x were to just go up by 1, y would go down by 3. So how are we going to find the y-intercept this time? Well, we're going to use this gradient. You see, I want to find out what is the y value when x equals 0. So if I go up by 1 from negative 1 to 0, I have to go down by 3. I have to go down by 3 because the gradient's negative 3. So when x equals 0, y will just be 3 minus 3, which is 0. The y-intercept is 0. So the equation of this line, the rule linking x and y, is just y equals mx plus b. Of course, you don't really need to write the plus 0 because it doesn't change anything. All right, that's all for linear relations. Let's now look at algebra. So first we're going to look at simplifying terms. We need to be able to add, subtract, multiply, and divide terms. A term is just a sequence of pronumerals and letters. 12x is a term, x is a term. You can tell terms as they're separated by plus and minus signs. So it turns out you can only add or subtract like terms, but for multiplication and division, you can multiply or divide terms even if they're not like terms. So when performing operations, you operate on the coefficients. Coefficient means number in front of. What that means is for negative 3a times 2b, all we do is multiply the coefficients, negative 3 and 2. So negative 3 times 2 is negative 6, and then we can just write the letters a and b. So let's look here, 4x times 2x. Well, 4 times 2 is 8, x times x is x squared, so we're done. What about 30y divide 10? Well, we just divide the coefficients. 30 divide 10 is 3, and we write the y, and we're done. So this one here is a little trickier. This is a division sign. Fraction line means divide. So we're going to first perform the operation on the coefficients. 40 over 60 simplifies to 2 over 3. Now, if you have a pronumeral, a letter on the top and the bottom, you can cancel out. That's the same as crossing out a common factors. So we're just going to be left with 2b on 3c. We can't simplify this any further. So let's look at these two expressions now when we're adding and subtracting. Now we can only add or subtract like terms. So here we have 3 terms, 12x, 3, and x. These two terms are like terms, 12x and x, because they have the same pronumerals, same sequence of pronumerals. So 12x plus x is just 13x. Now the 3 here doesn't have any like terms, so we actually just leave it alone, don't touch it. 13x plus 3 can't be simplified because 13x and 3 are not like terms. This has an x, this doesn't. So this one here is a little bit more complicated. Now note that st and ts are like terms. These two terms are like terms. They both have one s and one t. It doesn't matter the order in which the pronumerals are written. So note this last term is not 3ts, it's negative 3ts. The coefficient or number in front of ts is negative 3. So 8 minus 3, we just perform the operation on the coefficients. And then we can write st or ts, it doesn't matter in which order. So it turns out that these two terms are like terms. Now, this first term is not 4t, it's negative 4t, and this is negative 5t. So we perform the operation on the coefficients. Negative 4 subtract 5 actually gives us negative 9. So this can't be simplified any further. These two are not like terms because this has an s, this doesn't don't have the same sequence of pronumerals. All right, let's look now at expanding and factorizing. So to expand brackets means you start with brackets and we're going to end up with an expression that has no brackets. To expand, we use the distributive law. You distribute what's outside the brackets to everything inside the brackets. So here we go, 7 times 2a is just 14a, and 7 times negative 3c is negative 21c. So here, this one's a bit trickier because we have a negative and 3 terms. We're not going to do it any differently. So we go negative 5 times 4 is negative 20. So negative 5 times negative a, and negative times negative is always positive. It'll be plus 5a. Negative 5 times negative 6b. Once again, answer will be positive, and we're done. All right, let's now look at factorizing. So factorizing is the opposite of expanding. That's when you take an expression like this and you write it with brackets. This expression is factorized because it's something times something. So factorizing and expanding undo each other, just like multiplication and division. So to factorize an expression like this, we write the highest common factor of each term out the front. So 8x and 24 are terms. The highest common factor is 8. 8 is the highest number that goes into 8 and 24. So we write it out the front, and then inside the brackets, we divide each term by the highest common factor. We go 8x divided by 8 is x, or 24 divided by 8 gives positive 3, and we're done. If you were to expand this, as we did above, you would get what you started with. So sometimes the highest common factor also has a letter. So for 16 and 24, 8 is the highest number that goes into both of them. But this term and this term also have a y in common. So we write the y at the start. So now we say, what do I times by 8y to get 16yz? Well, you need to times by 2 to get to 16 and a z to get the z. What do you times by 8y to get negative 24y? Well, you need to times by negative 3. Once again, if you expand this, you get this, what we started with. So note, inside the brackets, there should be no common factors between the terms. All right, let's look at our final topic on this video, which is equations. So equations can be identified by the equal sign. What we need to be able to do is solve equations. That is, come up with a number we can substitute for the pronumeral that makes a true statement. Now, a lot of you will be able to come up with this off the top of your head, but we need to have a process for the times when you can't do that. Sometimes the solution might be x equals 7.2. So you'll be sitting there a long time to try and come up with it off the top of your head. So the process I'm going to show you is flowcharts. What we do is we tell the story of what happened to x. So in this equation here, we took some number x we don't yet know, we added 2 and then timesed by 8. I know I did things in that order because of BIDMAS. What happens in the brackets comes first, then we multiply by 8. So we took x, some random number, then we added 2, then we multiplied by 8, and then somehow got our answer of 52. So when we're solving, we reverse the order, and we do the opposite operation. So instead of timesing by 8, I'm going to divide 8. Dividing 8 is the opposite of timesing by 8. So 52 divided by 8 is 6.5. So then instead of adding 2, I'm going to subtract 2. 6.5 minus 2 gives me 4.5. The answer here, you've got to write it like this, is x equals 4.5. That's the solution, because if I change x to 4.5, I get a true statement. So yes, the answer doesn't have to be a whole number. All right, let's look at these two equations. They have the exact same operations. The only difference between them is the order of operations. And we'll see that if the order of operations is different, we get a totally different answer. In this equation here, we took our unknown number x that we don't yet know, we subtracted 6 first, then we divided by 3 and somehow got our answer of 5. So when we're solving it, we start at 5. Instead of dividing 3, we're going to times by 3. So 5 times 3 is just 15. And instead of subtracting 6, we're going to add 6. So 15 plus 6 is 21. The solution here is x equals 21. But in this equation down here, we actually divided by 3 first. So our flowchart's going to be the same, but the divide 3 and subtract 6 are just in a different order. So we still got our answer of 5, but this time when we're solving, we're going to add 6 first. So 5 plus 6, of course, just gives us 11. And then instead of dividing by 3, we're going to times by 3. And we get our answer, x equals 33. So that's the solution, because 33, if I substitute for x, I get 33 divided by 3, 11, minus 6 equals 5. That's a true statement. So let's look at this last equation here. People tend to find this tricky, identifying the operations. So this is not actually a subtraction, though it looks like one. We've actually taken x and multiplied by -5. Now that had to happen first because of bid mass. So we took x and times by -5. Then what we did was add 34. See, this 34 here is a positive 34. Okay, and then as usual, we somehow got the answer of 79. So that's the hard part. Once you've got that, solving it's just like all the others. Instead of adding 34, we're going to subtract 34. So 79 minus 34 is 45. Now, instead of timesing by 5, to undo that, we need to divide not by 5, but by -5. So negative and a positive divided gives a negative answer. 45 divided -5 is -9. The solution here is x equals -9. Once again, that's the solution, because if you substitute for x, you get a true statement. 34 minus 5 times -9 does equal 79. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.